Hi folks, it's Ron and welcome back to the channel and another part of my residential network cabling series of videos I'm trying to put out there for you. And hopefully you're learning something new from each of these different videos. And this is actually part 5 of, I'm not sure how many parts is it going to be in, but it's going to cover UTP cable installation and a little bit about category wire and that kind of good stuff and what to think about when purchasing and installing it. And one of the interesting things in this industry is the acronyms go out the wazoo as far as the types of acronyms we might have in this industry. And so a lot of people get kind of confused based just off of some words we use like propagation delay and delay skew and nearing crosstalk and all these other little things. I'll talk a lot about that stuff, and we talk about testing of category cables towards probably the end of the series of videos, but I just want to talk about the cabling itself and hopefully lay bare some of the things you should know and don't know about this cabling as you're buying and using the type of cables. Now, as a general term for all category wires, we refer to it as a UTP or unshielded twisted pair. And obviously you can buy shielded versions, which is STP. And as far as argument between shielded and unshielded, you know, we'd like to think a properly installed, properly terminated UTP system should not have the need for shielding. Now, if you're in a noisy electrical environment or you have a reason to go for shielding, shielding your cable helps cure several little problems as far as outside noise bothering what's going on inside the cabling. Might be a little bit more money, but as a general rule, really not a whole lot harder to terminate. But so basically, two types of wire there you've got. Now, when you look at all those cables, they will have 4 pairs as a general rule in them, and those 4 pairs are color coded. They're blue, orange, green, and brown. And line 1 is supposed to be blue, and line 2 is supposed to be orange. Line 3 is supposed to be green, and line 4 is brown is line 4. And so, and if you want to know more about wire color code configurations, I certainly have a couple videos up on that, especially as we talk about terminating, category wires, that kind of stuff on the channel. And the colors are part of the standard. So, do you have to make line 1 blue? The answer is no. More than likely, any color would work, but somebody coming in behind you would expect line 1 to be blue. Now, it says here on the screen that the pairs reduce crosstalk and noise in the signal. And crosstalk or noise is signal being generated from one conductor to another and actually interfering with that other conductor. You can actually induce a signal into a conductor. And I bet you a lot of y'all have been on a phone line in your lifetime and you're talking to somebody in the background. You can faintly hear somebody else talking in the background. Very simply, you got 2 telephone pairs sitting very close together in a bundle. I'm going to put a current down a conductor. It's going to radiate that magnetic field. That magnetic field induced a little bit of voltage into that other pair, and that's what you faintly heard was this other conversation. And in an old phone circuit, not such a big deal, but in data, it's a big deal. So we got to eliminate this. So how do we do that? And one way of doing that, believe it or not, is to twist the pairs. And one big difference between category wire and UTP cabling and old phone wire is that the old phone cables were not twisted, the pairs were not. So. And the more we twist, the more we tend to eliminate. And the way it does that is we actually inject a signal down a pair of conductors to send that signal to another device. Now, basically what they'll do is they'll take part of that signal and inject it into one of the 2 conductors on that cable. They have a means of inverting the signal on the other half of that cable. So the 2 signals being sent are equal in strength, but they're different in polarity. And so the 2 magnetic fields that those 2 conductors create are opposite in polarity and at the same strength. And when we twist the conductors the pairs together, that tends to cancel. And the more we twist, believe it or not, the more we eliminate. And that's really the big difference in all the category wires you'll find out there as far as what's the difference between Cat 3 and 5E is they twist the pairs quite a bit more. And we'll talk about twisting of pairs as we go forward here. Now, it also mentions here it has a varying parallel, and essentially what they'll do is they twist all 4 pairs at a different rate and then twist those together at a specific rate as well. And it can vary from manufacturer to manufacturer how they actually twist the conductors. Standards don't really tell them how to do it. It's just that they tell them what it should be able to do once they get done manufacturing the cable. And as long as they've done that, they don't really care how they made the cable per se. So each pair is twisted slightly different. And the reason we do that is because if we twisted all the pairs at the same rate, the electrons would travel down all four pairs at the same rate, and we again would be getting more and more noise or crosstalk. And applications like Ethernet allows 50 nanoseconds of delay between the fastest and the slowest pairs, because the more we're twisting in the conductors, obviously the longer those pairs have to be versus the ones that aren't as twisted as much. Okay. Now, the insulation they use for the conductors in this cable can vary from manufacturer. They mentioned polyolefin here, but it could be other things. We'll talk about what riser cable is, and that's what the CMR stands for, or plenum rated cable. We'll talk about it here in a minute. And it's basically just the fire rating of the jackets, but we'll talk about that more in a second here too. And again, as a general rule, all these wires are generally 24 gauge. However, at Cat 6 and beyond, we've gone to 23 gauge on the conductors, but normally 24. Now, all UTP type cables are what's referred to as balanced twisted pairs. And as I said a second ago, what they do is they send those signals down a pair. Half the signals go down one conductor, half down the other conductor, and again, they're balanced and twisted at a certain rate. Now, this type of cable construction is very resistant to outside noise or interference causing problems on that cable. Coaxial cable, I think I mentioned on an earlier series, is considered to be unbalanced, and it's very susceptible to outside noise. So, category wire is not that way. So, you can actually get a little closer to power lines than you would coax. Now, it's considered to be a 100-ohm cable, and that means the connectors and the routers or switches or whatever it is that run this signal goes through are also referred to as 100-ohm as well. And you'll actually find out in the specifications it's rated for 100 ohms plus or minus 15%. So the system is designed to take a very big swing in impedance, but keep in mind anytime we see a difference in impedance, it's a bump on a road basically due to the signal. And most of the signal gets past that bump, but some gets reflected back at us, which is another parameter we measure, which is called return loss, which we'll talk about later. So obviously we don't want a lot of bumps in the road. So, but you'll find that Ethernet is a very robust system. They actually designed it, the cabling system, for it to be really a tank, so to speak. Now, when you look at a little bit of the history here of these category levels and things like that, the different types of wires that have been around, two main parameters we'll look for when we're comparing cables, and one is the frequency range of the cable. It's referred to as the bandwidth of the system, and the higher that number is, the bigger the bandwidth, the bigger the pipe necessarily is, and the more information we can pass through the pipe. So that's one key parameter. And the other key parameter here is the data rate, or the information carrying capacity of the cable. And you'll find a lot of these cable systems or cables were designed for certain applications like 10 base T Ethernet systems or 100 base T or whatever the system it was trying to support. Now, in the late 80s, Annixter actually came out with what's called the Level program, and they came out with what's called Level 1 cable, and which is basically old telephone wire, old quad wire, never meant for data work, phone basically only. And then they also came out with what's called Level 2 type cable, which is really the kind of the first cable data wire you'll find out in the industry. And it was only rated for 1 megabit of speed and at 1 megahertz in frequency. Now, Cat 3 comes out in, I don't know, it was late 80s, early 90s, whatever it was. And Cat 3 wire was really designed to support 10 base T Ethernet systems. And you'll see the application on the right over here, it says 10 base T. And it has a frequency range of 16 megahertz and a throughput of 10 megabits per second. If, again, everything's working perfectly kind of thing. Okay? Now, Cat 4 cable came out, and it was really kind of pushed by IBM and referred to old token ring data systems. And you won't find it anymore, by the way. You won't find level 1 or 2 anymore either. And you can see that the frequency jumped to 20 megahertz and up to 16 megabits per second, but it died very fast. Then Category 5 wire comes out, and it was designed to support 100 base T Ethernet systems, which are the next rung up the ladder for Ethernet. And so we went from 10 megabits per second to 100 megabits per second. And so Cat 5e cable supported 100 megabits per second, essentially Ethernet, at 100 megahertz in frequency. So the pipe significantly got bigger over Category 3. Now, you'll find that Cat 5 cable was not quite capable of supporting gigabit Ethernet at the time. And so over a very short period of time, I'm talking just a handful of years, gigabit Ethernet comes out of the market, and a lot of people had already rewired their buildings with Cat5 cable, and we're finding out we're having a little problems with Cat5 cable. And so they came out with Cat5e cable, and E means enhanced, and you'll notice still rated for 100 megabits or megahertz in frequency. The frequency did not go up on the cabling, but because of the way we're doing our twisting in the pairs, it's tighter on Cat5e versus was Cat5. It could support gigabit Ethernet when it came out, and so we needed a cable that could not only support 10 and 100 base T, but something that might take us to the future. So that's, again, when 5E came out. And gigabit Ethernet at that time was very brand new, not a whole lot of installations installed with it yet, but it was coming toward the future. And physically, what's the big difference between Cat 3 and 5E? It is essentially the twisting of the pairs. And Cat 3 depends on who you bought and what pair in particular it was. You might three or four, maybe 5 or 6 twists in a foot in the cables. Cat 5 may have gotten into the mid to low teens in twist rates per foot. 5E, again, depending on who you buy it, could be probably high teens, maybe low 20s in twists per foot. Cat 6, which is the next rung up the ladder, you'll find maybe mid to high 20s, maybe low 30s in twist rates. And 6A, that stuff's really twisted. You're talking 40, 50, 60 times a foot, so it's twisted pretty tightly. And 5E is king for a number of years there. And how do cable manufacturers kind of differentiate themselves from other cable manufacturers? Is they will make a souped-up version of Cat5e cable. So Cat5e says it only has to be ready for 100 megahertz, but can support a gigabit Ethernet. But a lot of manufacturers were making cable higher grade than that, and of course the argument is always put in the best quality cable you can when the walls are down, because you'll be ripping it out somewhere down the road. So a lot of manufacturers were making Cat5e rated to 250 megahertz and beyond. And so after a number of years go on here, and the transition to gigabit Ethernet become pretty prevalent in the industry in the late 1980s, basically we came up with a Cat 6 rating. I mean, cable manufacturers were already making a cable better than 5E. And we needed a cable specifically kind of for Cat 6 or gigabit Ethernet installations. So Cat 6 cable is really a cable designed for gigabit Ethernet. And you'll notice on the chart, it's rated for 250 megahertz, which so they 2.5 times the size of the pipe. And but the speed's the same, 1,000 megabits, right? And the reason is because there's nothing faster than that right now, that as far as a standard is kind of concerned, right? So here we are a number of years later down the road, and 10 gigabit Ethernet becomes something that actually is happening in the industry. And so Cat 6, will it support 10 gig applications? And the answer to that is it could. Now, will it support it to 100 megahertz and 100 meters in length, I should say? The answer is we don't know. Probably not. You'd have to test. Okay? So if we need a new cable for this new thing called 10 gigabit or 10 gig base T Ethernet, so we came up with Cat 6A cable here just a couple of years ago. It became kind of a ratified, approved thing. And so it's rated for 500 megahertz in frequency, so 2 times what Cat 6 was, and is ready to support, again, 10 gig base T data networks, or 10,000 megabits per second. Okay? Now, just so you know, there is a Cat 7 in Europe, very similar to what we have here as far as 6A is concerned, and we are on the beginning of Cat 8, and I'm hearing, and it's going to support 40 gigabits per second. Is the speed for 40 gigabit base T data networks over copper cable systems. Right now, the standard, they're looking at maybe over 50 meters, not 100 meters, because a lot of these backbone cables don't need to be 100 meters in length. So who knows when exactly this is going to get approved, but we're talking in the next probably year or two, so maybe sometime in 2015, we'll be seeing a Cat 8 wire. And will we ever have a Cat 12? We might. And every time I think the copper guys can't possibly go any faster with copper, they find a way. And another interesting thing I'm learning is that as the RJ45, the connector we use, the modular plugs and jacks, we are beginning to max out the frequency ranges that those connectors are really good for, because we're talking 500 megahertz in frequencies and beyond, so what that new connector is going to end up looking like, I'm not 100% sure, but I'm hearing the Cat 8 specifications are going to be using RG45s as well. So we'll see what the future holds for us with those new cables. So that's kind of a little bit of a history of what has kind of happened in the past. Now, every time we jump up in frequencies, we have more things we test for that we didn't test for with Cat 3 or Cat 5e. So, and you'll find the parameters get a little tighter too, as far as how much headroom we can have in that particular measurement we're taking. And one new one out there in the industry is called alien crosstalk. It's really not new; it's been around a few years. And it's interesting. The industry does not tell us how to measure for this. They don't tell us how to test for it. They just tell us there's one more thing to look at when we're installing systems. And we used to always be worried about what's going on within the cable itself, inside the jacketing, not really what's going on outside. So we don't really care what the cables around it are doing to the one in the middle. In Cat 6A and beyond, they are beginning to measure and think about this. So something new is called alien crosstalk. Well, so they'll find a victim pair, usually in the middle of a bundle, and then they'll see what those, say, 6 pairs around it are doing to that victim pair in the center. And a little later on, if we get a chance to talk about certification testing, we can talk about how you go about measuring for this in a building. You'll find out that you cannot do 100% alien crosstalk testing in a building. Almost impossible to do. But you can pick some fights, so to speak, in a building. And so just one more parameter you may not have heard of in the past, so alien crosstalk. There you go. Now, a very important parameter that you should know about any type of cable you buy and install in buildings is what is the UO or flame rating of this particular cable, and what's it rated for as far as the NEC, the National Electric Code, is considered. And when you look at the National Electric Code, it basically has 4 designations here on cabling. And the lowest rating is called CMX, and typically I find it's limited purpose, and a lot of times I'll find it dual rated where it says CMX/CMR, which is riser, and a lot of times I find that cable used for indoor-outdoor cable. So you go out the side of a house, on the side of the home, go up the side of the home, up into the second floor, come back in the house and start pulling wire again back inside the building. So there is a cable that it actually has a UV inhibitor in it so the sunlight doesn't break it down, the jacketing in the sunlight. But there's an example of a limited purpose type of cable. General purpose cable, CMG, a lot of your patch cords are utilized for that. General purpose cable is typically designed for horizontal runs, not really meant to go vertically through buildings because the way it burns in a fire, it puts off toxic fume and dense smoke and things we don't really want burning in a fire, but fine for things like patch cords. Inside of walls, as a general rule, you're going to be told to run riser-rated cable, and you'll find it will say CMR on the cable someplace. CM stands for communications grade cable, by the way. It might say MPR, which is multi-purpose, but the last letter is the one you want to know, which again tells you what its flame rating is. And riser cable, supposedly, if you catch it, if it's going vertically through a building, you catch it on fire on the bottom of the cable, you take the heat source away from it, that flame should go out within a predetermined distance set by UL, and the amount of smoke it puts out should not be as toxic and as dense, so you can hopefully see through it in a fire. So there's an application for riser-rated cable, and a lot of your applications will be riser-rated. The highest rating is plenum. And plenum-rated cable can go anywhere in a building. You can go down this or up this list where plenum can be installed anywhere, but riser and general purpose, they all have their place. And so plenum-rated cable is usually about 3 times the price of riser, so you'll immediately know you got plenum in your hand when you look at the bill. And generally you can tell it's plenum because the jacketing on it that makes it plenum-rated in many cases does not hold ink very well. And you'll notice that those plenum cables, the colors are pretty faded. Blue looks a lot like green, and brown looks a lot like orange. So I can quickly tell if it's plenum, usually just by how faded the colors look. And plenum-rated cable is designed to go through parts of the heating air conditioning system or part of the air plenums in a building. And you'll find a lot of drop ceilings in office buildings are actually just part of the heating air conditioning system, and there's a blower blowing air across that ceiling or sucking air across that ceiling is pulling air out of the rooms. And so the entire area above the ceiling is part of the heating and air conditioning system. And if the wire is going to be ran in those kinds of areas, you have to run plug them. And that is probably one thing that your inspector will definitely know is out there in the field. So be looking for that on the cables as well. Very important one to know. Okay. Now, as far as installing cables in buildings, as a general rule, I'm going to tell you to try to be one of the last trades on a job, especially in residential. Commercial work, that's not going to happen. But because if you're drilling holes and installing wires in a building and you have a large hole drilled and just a few cables passing through it, somebody coming in behind you can easily add their wires to that opening and maybe cause you some troubles. Also, when you set up things like pulling stations in a building, make sure they're clear of other trades and people stay out of that area and they're not walking across your cables and potentially damaging your cables as well. And also make sure you're labeling your cable. It's very important to label your cables really on both ends so we know where the end of that cable goes. And follow the 606 labeling scheme I mentioned in one of the earlier videos I had up. But again, just do a nice job installing your cables. And as a general rule, I'm going to tell you, always hide them too. Do not leave cables exposed because people do stupid things like hang Christmas ornaments and other crazy things on cable. So, and end up damaging the cable in the process. Now, as far as handling the cable and getting it ready to be pulled, as a general rule, we'll tell you to make sure you climatize the cable to the environment that it's going to go into. In most parts of the United States, it's not a problem. But obviously in the northern parts of the country, or obviously up in Canada and Alaska, we can get some very cold environments. And that jacket can be damaged in the process of really basically taking it off the reel. And especially in cold weather environments, leaving a little extra slack in connections is not a bad idea. Just for the pure fact that cable will shrink some, obviously during the cold span. So you can kind of climatize your cable to the installation. And as far as handling the cable, again, make sure that when you pull the cable off the spool right out of the box, it's not getting kinked as it comes out, because in many cases you're pulling multiple runs of cable at one time, not just one cable at a time kind of thing. And again, make sure when you're pulling around corners, you're using those pulleys and other things to make sure we not damage the cable during the process. And again, don't let it get stepped on or crushed in the pulling station as well. And we tell you don't kink your cable, and I'm going to tell you during the process of these classes, if you haven't heard me say it, especially with 10 and 100 base T, you can stomp on that cable. It's probably going to work. Now, nobody recommends this as a general rule, but you'll find it's pretty robust. But anytime you deform or the shape of the cable in the process, you're basically causing a bump in the road. And the more we do this, obviously, the more problems we could potentially have. But again, as a professional installer, the idea is not to damage the cable in the process. That if you're one of those type of folks, that'll catch up to you sooner or later. So again, try not to damage the cable in the process. Pulling tension is a really good one to kind of ask people about. And it's interesting, as far as pulling tension on the cable, what should that be? Well, the best answer to that is go check with the manufacturer who made the cable. They should probably have a suggestion on how to pull it, especially with fiber optic. How do you pull with, obviously with the Kevlar string, not with the fiber. And so they might have some tips for you. But the industry says for category wire, 4-pair wire, 25 pounds of force. Well, how do you measure that? The answer is they don't. They assume if that cable passes a certification test after you've installed it, you must have pulled it right? And over the years, we've actually tried to come up with a couple different products to help measure this, but you just couldn't get anybody to use it. And so it's 25 pounds if you haven't heard that. And again, on other cables, check with the manufacturers. And if you're pulling multiple cables together on one pole, what's the number? Again, I would suggest you talk to your cable manufacturers. Maybe they will have a suggestion for you. But 25 pounds for a single cable is what the standards kind of recommend. Now, when you find routes through a building, as I said earlier, we like to stay out of areas other trades like to be in. Sometimes that doesn't happen, but and when you're laying out cables in a building, as I said earlier, make sure they're covered. Don't leave your cables exposed as a general as a general rule. Avoid sources of EMI, so ballasts, any fixtures or motors or blowers or anything else that might put out a lot of EMI, and finding those sources of problems can be a lot. I got a good buddy of mine that moved into a brand new house, and the TV in the living room looked great as long as you didn't turn on the oven in the kitchen. And obviously, the electrical oven in the kitchen wire ran very close to the coax, and it was causing interference. And again, finding those trouble places in a building is almost impossible. And by the way, that ceiling there is the drop ceiling is not there to support your cable. Although in a lot of office buildings, you can look above a drop ceiling, and you're probably going to find wire draped across the top of the ceiling. The standards recommend supporting your cable in the ceilings every 4 to 5 feet, and refer to people like Caddy Fasteners for a myriad of different types of fasteners they have up for supporting data networking wire in ceilings, like J hooks and other stuff. And again, they have a certain design they use to make sure they minimize the weight bearing that cable has to tolerate, especially if you bundle 50 or 60 or 100 cables together. And so there's a myriad of ways of hanging that stuff in the ceilings. Just look into it. Bending radiuses on cable, again, as a general rule on UTP cable, we say it's 4 times the diameter of the cable, so whatever that happens to be. And a lot of your category cable are roughly 1/4 inch, and so 4 times that is an inch. That's the radius of the bend, not the diameter. So it's a 1-inch radius. Now, if you bent the category wire in a loop, how tight's that loop? It's basically a 2-inch loop is the tightest they want you to bend it, believe it or not. And, of course, Cat 6A wire and bigger conductors or cables are even a little bit more than that. STP is 8 times the outer diameter, and I'm not 100% sure. Probably something to do with the foil shield inside the cable not being deformed, but they're 8 times on the STP type cables. When you're bundling cable together, and what do you use to bundle it together with? There's a lot of different devices out there today. You'll find from basically cable ties to Velcro cable ties, and there's some actually very cool wire management devices they use today to help straighten out that bundle and make it look nice and neat. Over the years, we've learned not to pinch the cables with the cable ties and deform the shape of them. That's not good. We want the cable to be tie to be snug, but not damaging the cables. We used to like to make really nice tight bundles out of these cables and make that bundle look really neat. And they're finding out with Cat 6A, as I mentioned earlier, with alien and crosstalk being one more thing we're looking at, they're telling you not to bundle them so tight. Depending on the cable, how do you handle that wire management is kind of up to the particular job. And again, if you're putting cable ties up in a drop ceiling or something like that, you probably ought to be using plenum rated cable ties to do that. So there's a lot of different ways of making sure you're managing that cable bundle properly and not damaging it in the process. Now, as I said earlier, make sure your cables are never exposed, because one main thing that happens to them over time, it's going to happen, is they're going to get painted. And when those cables get painted, that basically ruins any fire rating on them and any warranty you might have gotten from a manufacturer out there on the cable installation. So just be aware of, again, try not to leave them exposed, and because, again, eventually they will get painted. I can almost guarantee it. Now, cable slack at either back at the telecommunication outlet or back in a telecommunications room has changed from what we used to think about 15, 20 years ago. And so today, the standards basically recommend that if you're in a telecommunications rack, no more than 10 feet of cable, or about 3 meters, is left coiled up above the rack someplace, okay, for moves, adds, and changes that might happen somewhere down the road. Now, at a telecommunication outlet in a room, the suggestion is up in the ceiling, no more than about 1 meter or 3 feet of slack. Now, at the telecommunications outlet, we will say no more than about basically a foot, 8 to 12 inches, or a foot of slack in order to re-terminate that particular outlet. And if you ever had to, you might pull down some more from up in the ceilings. Now, as you can see on this slide, you got all these bundles up above in the ceiling. There's a bunch of coiled up bundles up there, right? That's a very common practice from years gone by, and because, especially in an office building, and you got a partitionable furniture underneath the ceiling, And that furniture is going to get moved occasionally, and having an extra 50 or 100 foot coiled up above in the ceiling, especially if you're nowhere near the 90-meter rule on that particular cable run, was nice to have, because you would not have to pull a new wire off the rack to move that particular office. So that was a very common practice. Now, as we progressed in speeds and frequencies keep going up and up, today we're telling you that that's not a very good practice, because that 100 ohms I talk about, that impedance, there's three factors to that. One's called inductive, one's called resistive, and one's called capacitive reactance. And actually, capacitive reactance is the big one, but one is inductive reactance. And as you coil that cable up, what happens is those magnetic fields are adding up, and you're changing what's called the inductance in the cabling, which is affecting that 100 ohm thing. So that's why they tell you don't do this anymore. And they tell you if you're going to install excess cable up in them ceilings, and you go beyond the 10 feet, then you start putting in stored in a loop figure, kind of a figure 8 type of figure, and that will help stop those magnetic fields from adding up like that in that coil. So put it basically in a figure 8 if you're going to put a whole lot of slack up there in the ceilings. Okay, but that's kind of a big one that's changed in the last 15, 20 years that we always did. Okay. And then lastly, when we look at terminating the cables and we put a connector on the end of this wire, you'll find all the connections you run across will tell you to leave no more than a ½ inch of slack, either a patch panel or a jack or in a modular plug, when terminating the ends of the catenary wire. And as I said earlier, you can kink it, you can knot it, you can bend it in a lot of cases, and things work fine. Just don't untwist it. And you'll never retwist that wire like the machine twisted it, and technically it's supposed to be twisted at a very specific rate throughout the entire length of the cable. Although if you retwisted the cable, would it pass a certification test? It might, and probably would, but just be aware of a ½ inch is the maximum we're allowed to leave untwisted per connection when we're working out in the field. Okay. Well, I hope that helped a lot for you, and we'll move on to the next segment, which I'm not quite sure what that is, but we'll figure that out. And if you haven't done it, do me a favor, subscribe to my YouTube channel, folks. I really do appreciate you all watching that thing, and I'm always surprised at how many of y'all do watch it. So, again, if you haven't been to my channel, please subscribe. And thanks for watching again. I appreciate it. And my name is Ron with Ideal, and I'll plan on seeing you hopefully on the next one.